Hi all, welcome back to Whoops with C++ session 32. In previous session we have seen how to use constructors, that is zero argument constructor, parameterized constructor, and also we have seen how to use the conversion constructor. Okay, and there is one more type of constructor, that is copy constructor. Okay, so before going to discuss about copy constructor, you should be having some basic idea on dynamic memory allocation techniques. If you know that, then understanding copy constructor will be easy. Okay, so that's why we will focus on dynamic memory allocation techniques in today's session, that is how to use DMA techniques in C++ and as well as what are the ways and how in what ways we can use DMA techniques in C. Okay, now let's focus on DMA techniques in C++. Okay, so what is this DMA? That is dynamic memory allocation. See, don't get confused. So here DMA, I am just referring to dynamic memory allocation. So with respect to OS, there is something like a DMA means direct memory access. Don't get confused with that. So just for convenient, I am using this as dynamic memory allocation as DMA. Okay. So DMA is achieved using pointers in C++, and whenever I am talking about dynamic memory allocation, we are referring to heap memory allocation only. So previously we have discussed that we have some memory segments like stack memory segment, heap memory segment, data segment. Okay, so these are all different types of segments. We have seen if anything is allocated memory, so if you are creating any local variable inside a function, then it will get memory in stack segment. If you are creating any variable in global section, then it will get memory in data segment. And we have also discussed that if the variable is getting created inside a function, then it will the life of that variable will be till end of that function. And if the variable is created in globally, means globally, then it will get memory in data segment, and its life is throughout the program lifetime. Okay, so now what about this heap memory then? So heap memory is completely under control of the program. So what do you mean by it is under the control of program? Means as and when you need the memory allocation for the pointer variable, you can allocate, and when you don't want, you can remove it. So which is it is completely controlled by the user or programmer. Okay, but how about the other memory location, stack memory or data segment memory? So that is not under your control. Okay, it is completely controlled by the OS. Okay, so DMA is a better way of handling available memory. So when we talk about process speed, resource, mainly we will talk about our RAM memory. So whenever you are running any program, your program will be running under on RAM. So in that case, if RAM size is less, you have to efficiently handle the memory. Okay, so hardly 8 GB, 16 GB, something like that you will be having. Now 64 GB, it's coming, but RAM is costlier. So you should not occupy more memory. Okay, you have to do better memory management. You have to use better memory management techniques so that you can use less RAM space in your system. So that we can achieve by using DMA. Okay, dynamic memory allocation techniques. So by using pointers, we can access the heap memory and can perform the operations. Okay, so pointer is pointing to the heap memory address, so where your values will be stored, and you can directly you can initialize those memory, or you can access those memory by using pointers. Okay, so now, so then why it is required dynamic memory allocation? Just quickly observe this example. So in main, I have created an integer array of 100 bytes. So how many bytes of memory will be allocated for this in stack memory? So it is totally 400 bytes, 100 array locations, and each array size is 4 bytes because it is an integer array. So array into 100 into 4, 400 bytes of memory will be allocated. And when it will be allocated? as soon as your CPU control is going to execute this particular function, and whenever it is encountering this line, so immediately what will happen is in the stack frame 400 bytes of memory will be allocated for this array. So array of size 100 will be there, and it is total size is 100 bytes, and it will be getting memory in the stack segment. Now assume you have some code. After this code, maybe in this particular line you don't want this array. Okay, and after this line also assume you have some around some maybe 100 or 200 lines, maybe some 100 lines of code is there. Now what will happen is till your CPU control encounters this closing braces, till that time this memory will be available. So it will be, even though you don't want this array after some particular line, maybe after some 100 lines you don't want this code, but even then you cannot remove it from the memory, so it will be available, you cannot free it. So, and it will be freed only when the function is getting closed. Okay, once the CPU hits the closing curly brace, so it will be removed from the stack frame, and entire stack frame will also be removed. Okay, you won't be having control over the site. So it is like after this particular line, it's waste only. It's simply I'm not able to give that memory to any other variables also, right? So that is the reason here memory we are not utilizing efficiently. Okay, now what will happen if I use dynamic memory? That is, so in C++ we are using something like new and delete to allocate memory and deallocate memory location in heap. So now if I am using pointer, then I have to use, if I'm going for a dynamic memory allocation or heap memory, you have to use pointer. So for example, now instead of array, say instead of array, what I'm using is int star. So here previously int ARR of 100. Now what I'm doing, so I have just created a pointer ARR. So in this previous case ARR size is 400 bytes. Now here ARR size is pointer, because all pointers will hold 4 bytes of memory location. Now int star ARR equals to new int 100. As soon as the the CPU control executes this line, what will happen is in stack frame there will be 4 bytes of memory will be created for this ARR. And since you are using new, as and when you say new, then what will happen is there will be another heap segment. In the heap segment, some 100 bytes, 100 locations will be allocated, and each location size is of 4 bytes, because it is integer. So now 400 bytes of memory will be allocated, and this starting address will be given to this array. Now ARR is holding 0xAF1234. Maybe assume this is an address of this 400, starting location of this. So now it is 400 bytes. Okay, now this pointer ARR is a pointer which is pointing to a heap memory address where we have 400 bytes. Okay, now maybe after some code, what you are doing is after this code we are deleting this array. So when we say delete ARR, so then what will happen is this heap segment memory, whatever is there, that is removed. Now I have done with this task. Now how many bytes of memory I am having? So but this ARR is there, right? This will be there till end of the stack, because whatever memory 400 bytes you have allocated, that is in heap segment, but whatever this integer pointer in star ARR is there, that is still a local variable. This 4 bytes will be there till end of the program. So now totally how many bytes of memory will be wasted throughout the function? Only 4 bytes. But in the previous case 400 bytes of memory we are wasting. Now we are wasting only 4 bytes of memory once we have done using the ARR. Now as usual, once you hit the once CPU control hits the closing curly brace, then all this will be removed from the memory. Okay, so like this we can handle the memory in efficient way if we are using pointers and heap memory. Okay, so now, so how to allocate memory and deallocate memory? So for that, as I said, DMA is achieved by using new and delete operators in C++. And if you talk about the syntax, for a single memory location, what you can do is you can have data type star ptr equals to new data type. So this is memory allocation. It will allocate memory in heap segment, and if you want to initialize those memory, then you can use star ptr equals to value. So this one is memory allocation, and second one is memory initialization. Okay. So this data type may be anything, maybe integer, character, float, or any class pointer, anything. Okay. Now this is initialization. Now if I want, so there is one more method you can allocate and initialize. If you observe the first one, first is memory allocation, next initialization. So instead of two lines, we can write it in a single line itself. New data type within the function braces, you can provide the value. So this is memory allocation as well as initialization. Okay. So like this, we can allocate memory for the any pointer for a single location. Okay. We can allocate like this. Now, how to free this memory? To free that, we have something like delete operator. So delete ptr. So it will deallocate the memory. So memory deallocation. Now, so how to use for array of locations for memory allocation for an array? So same thing as usual. You have to use data type star ptr, then new data type here within the subscript operator, that is square brackets. You have to provide how many slots you want. Maybe array of size 100 or array of size 10, array of size 200, like that you have to give. Maybe array of size 10 I am giving. Or if you want to initialize, what you can do is you can start using the index value. PTR of 0 equals to some value, PTR of 1 equals to some value, PTR of 2 equals to some value. Like that you can use the array indexes to initialize. So for accessing also you can use PTR. Okay. So this is memory allocation and memory initialization. So now how to delete array of memory locations. Now this pointer is holding array of memory location inside heap. Now how to delete it? For that you have to use subscript operator, delete subscript operator ptr. So if it is a single location, then you need not to use a subscript operator. We should not use subscript. If it is array, we have to use the subscript operator to deallocate the memory. If ever we are not using subscript operator, then what will happen is only the first location will be removed and the rest of the locations will be kept inside the memory itself. It won't go. Say for example, now PTR, assume we have allocated array of 10 locations. Now this is in the heap segment. Okay, 0, 1, 2, 3, 4, 5, 6. These are the indexes, 0 index. Now what I'm doing, so PTR will be always pointing to the starting address. Okay. Now when I say without subscript operator, if I say delete PTR, then what will happen is only the first location will be removed, freed from the memory location, and the rest of the things will be still in the memory. So memory leakage will happen here. Okay. So whenever you are freeing the memory for the pointer for an array, so make sure that you are using subscript operator. Okay. So now after this, you have say let's discuss about the difference between C DMA techniques and C++ DMA techniques. I think you might be aware of C DMA techniques, like we are using malloc on free to allocate and deallocate the memory in heap in C language. Okay. So how we will write a data type star ptr equals to one casting operator we are providing, data type star malloc size of data type. So here why we need casting operator is malloc will always return void pointer. So but here data type is different. So void pointer has to be casted to the respective left hand side, whatever data type you are using, to that particular data type you have to cache. And also malloc is not that much intelligent one. You have to provide how much size, even though the data type, if it is an integer, for integer how much data type, that size you have to provide. And initialization as usual, star ptr equals to value. And to free the memory location, free ptr. So here malloc and free both are functions. Okay. Now coming to C++ DMA techniques, it is data type star ptr equals to new data type, and star ptr equals to value, delete ptr. If you observe here, we are not using any typecasting operator, as well as we are not using size of operator also. So new is an intelligent one. Okay, so star ptr equals to value delete ptr. You can use delete instead of free. Okay, now delete data type star array for array of locations. Array data type star malloc size of data type into n. Okay, so we have to give like this. Along with the size of data type, you have to provide into n how many slots you want. So here same thing, data type star array equals to new data type. Here in the subscript operator, you have to provide how many locations I want. Maybe array of 10 I want, array of 20 I want, array of 100 I want. That you have to provide. So to free the memory location, you have to provide free of array, that is fine. But when you are giving deleting array of locations, so for delete, you have to provide subscript operator. Here for while freeing array of locations, subscript operator is not required, but for delete, subscript operator is required. So and when malloc fails, when it will fail, malloc or new will fail when there is no sufficient memory available in heap segment to allocate to you. So during that time, malloc or new will fail. But when malloc fails, what it will do is it will return null value to the pointer, and but when new fails, it throws an exception of pad underscore class alloc class object. Okay, so exceptions are runtime errors. We'll discuss about these exceptions during exception session. Okay, so now just briefly recall our points. So malloc free versus new delete. So malloc function is used to allocate memory in heap. New operator is used to allocate memory in heap. So free function is used to release the memory in heap. Delete operator is used to release heap memory. So malloc uses size of and caching operator while allocating memory, whereas new won't use caching and size of operators while allocating the memory. So allocation and initialization of memory at the same line is not possible, whereas you can do allocation and initialization of memory at the same line by using new. Okay. So while freeing array of locations, free won't use subscript operator. That is, this subscript operator is not required. But while freeing array of locations using delete, you have to use subscript operator. If you are not using, only the first location will be removed from the memory. All other will be present in the heap memory like that only. Then it leads to memory leakage. So malloc will never call constructor and free will never call destructors. So here new will call constructors and delete will call destructor while dealing with the pointers to a class. So we'll see why this constructor calling and destructor calling is required in the upcoming sessions. Okay. So when just currently you just remember malloc will never call constructor and free will never call destructor. New will call constructor and delete will call destructor. This is the point which is making us to move from malloc free to new delete. So otherwise whatever malloc is doing, same things new is also doing. So you can instead of new, you can directly use malloc free also. Since C++ is having backward compatibility, you can use malloc free, calloc, realloc, all those things will work. Okay, but instead of malloc and free, always it is advised use new and delete in C++. So as I discussed, when malloc fails, it returns null, but when new fails, it throws an exception of reference to an object of class bad underscore or norm. So reference object it will return. Okay. We'll see how to catch that exception. If we are not catching that exception, what will happen that in upcoming sessions. Okay. So that's for today. Thanks for watching. Please like, subscribe and share. Thank you.